Good morning, organic students, or afternoon or evening, whenever you're listening to this. This video is going to be the introduction to oxidation and reduction. So it's going to be pretty short, and I'm going to be using the new oxidation and reduction handout. So we ended last semester talking about these reactions, but we didn't get to go into them in detail. So this is a basic review. So if you don't remember anything from last semester, here it is again. All right, oxidation and reduction. In a generic sense, we learned this in Gen Chem. And so oxidation, we always said, is Leo because it's the loss of electrons. That is dealing all the way down to the electron level. In organic, we don't have to quite go that far. It is also listed for us with the brackets with the oxygen inside. And remember, anything that is oxidized is called the reducing agent. So if I am the species being oxidized, I am forcing my partner to be reduced. So the one that is oxidized is called the reducing agent, and that's the terminology that we use more often in general chemistry. Now, if you go one step more generic, I guess, than using electrons, we can call oxidation, hey, I am gaining a polar bond. Now, again, usually that is an oxygen, but it doesn't have to be. Or vice versa, you could say it is the loss of a carbon-hydrogen bond. So that is generic oxidation. Well, reduction is the GER part of that statement. So Leo the lion says GER, it's gaining electrons reduction. And that is indicated by a bracket with a hydrogen. And remember, the piece that is reduced would be called the oxidizing agent. Oxidizing agent, because it's being reduced, but it's forcing the other partner to be oxidized. So we could call it the loss of a polar bond, specifically, an oxygen, or we could say it is the gaining of a hydrogen bond. Either way works for both of them. The key is we're going to start using the terms reducing agent and oxidizing agent a lot, and it just is the opposite of what's really happening to that species. All right, let's take a look at about the pattern for the oxidation and reduction in the organic molecules. Here I have written the oxidation all the way from an alkane to a carboxylic acid. And I'm going to go over to the other page so that we can see it in larger forms. And then down here, there's a special case that I will talk about. All right, so I'm going to leave this one and I'm going to go into my whiteboard. All right, so let's talk about the pattern of oxidation and reduction in organic chemistry. So I'm going to start with a generic alkane. All right, so just start with ethane. And then there's a pattern to oxidation. So the first step is you get to put on a single oxygen bond. So there's my oxidation symbol. So the first thing is a single oxygen. And remember, oxygen has two bonds. So when I say an oxygen bond, it really means an OH bond. All right, the next thing is you could double that bond up. So again, our next oxidation step would look like that. So now I have a double bonded oxygen. Now the next step has a big if associated with it. If there's a hydrogen to give, and what I mean by that, is there a hydrogen directly connected to that carbonyl? Okay, so not clear out here, not on the methyl. It has to be directly connected to the carbonyl. If that hydrogen can be lost, then you may put one more on. Okay, so if the answer to that question is yes, then you can put one more single oxygen on it. And for us, that would be as oxidized as we would get. There are a few cases where you could go one step further, called decarboxylation. And I have to use that term carefully because decarboxylation can be from an oxidizing and reducing agents, or it could be from heat. It means the same thing and yet different, but basically you're going to lose carbon dioxide. And so the absolute most oxidized state would be one carbon with two double bonds, but you have to have a special compound in order to do that. And so the only time we will see it, I will point that out. Okay, so generally we start at or stop at carboxylic acids. All right, let's go the other direction. Well, you can go from a carboxylic acid. The first step would be back down to an aldehyde. The next step would be back to an alcohol, and then you could go one last step and you could get all the way back to an alkane. And I make it look easy on the board here, but each of those steps has to have like a different strength of oxidizing agent or reducing agent. They're not all made the same. All right. And then that decarboxylation or the loss of carbon dioxide right there is shown for you. All right, and then I do a few examples for you. And remember, this is really generic. So I suggest you draw them out. Oh, look, it's an alkane going to an alkyl halide. Well, this is a polar bond, and it wasn't there before, so we would call that one oxidized. So those questions are very, very, very generic. And that is the basic introduction for oxidizing agents and reducing agents and how we use them in organic chemistry. So until next time, jolly out.